Hey guys, what's up? This is Rob here with Breaking Down Bitcoin. Just me here today. Brian couldn't make it, but I'm going to do what's hopefully a quick little video of just playing with my Bitcoin node and showing you kind of what, some of the pieces of it, through the command line and kind of just deep diving into a block and showing you what a block looks like, on the disk. Basically what a node sees. Because you can view it through, you can view blocks through a block explorer like blockchain.info or block cipher, and it'll give you a nicely parsed, breakdown of the block itself. But what I want to show you is just kind of what the raw data looks like and break it down from there. This kind of follows with our previous episodes where we constructed a transaction with a raw hex and then parsed that transaction and then submitted it over the testnet. This is just going to kind of show how those transactions, that raw hex, is actually stored and how the thousands of transactions are stored within a block. So I'm just going to dive in here. I'll just show you via command line here. First of all, I have let's see here. Just going to jump into my Bitcoin folder here in my user directory. You'll see that if I do a directory listing here, I've got a couple directories: blocks, chain state, database. Blocks is exactly what it is. It's the directory that stores the blocks for the Bitcoin blockchain, every single one from the beginning. I do not run a prune node or anything, so it's the full blockchain on here, which is roughly about 150 gigs. Probably getting closer to 200 here soon. There's also a mempool.dat file, which I believe stores part of the mempool, if not the mempool. I actually stopped syncing my node a couple days ago, and I just started syncing it again, so the dates are going to be a little off, but most of the files are up to date for the purposes of this video. Let's see here. Basically, we also have the wallet.dat, and that's if you were to use the node as a wallet, which you can. This is where your private keys and private keys are stored for transactions that you can actually execute using your node. And then there's peers, which the peers files, what I assume is it stores the peer node connections that your current node has, which I can just show you if I run what is it, Bitcoin-CLI get info. This will show me my node version, which is version 15.01. It'll also show me the current balance, which is 0 because I don't use this as a wallet, and then what basically the number of blocks that the node is currently up to. This is slightly out of date because it's still syncing. It's only up to 442,000, and I believe we're at like 498,000. But again, for the purposes of this video, I'm just gonna pull a random block and just dive into it. So it might be a little old. Let's see here. We also have the difficulty number here, and that's pretty much all I really wanted to show of this part. But what I really want to do is go into the blocks directory and just kind of show you a directory listing here of all the files. So what you actually see here is actually the raw files that store the blocks and the transactions. If I scroll up, you'll see the BLK files. I'll scroll to the top, and you'll notice that they're not named after the block numbers. This BLK 00001 is actually not a block 1. This is actually a 134 megabyte file that has many blocks. It likely has the first block in it, that was ever mined, but it also includes many blocks after that to a total of 134 megabytes. So what I'm going to do is just go ahead and do a command to kind of show you what that block contains, the raw hexadecimal, which it's not going to really make much sense, but I'm going to break it down a little bit more to help you understand it. And let's go ahead and just pull up this file. This is one of the most recent blocks that I have synced. I think it's from about 6 days ago. So I'm just going to run this command xxd, which basically dumps the hex output of that file onto the screen. This file is a binary file, so it's just all zeros and ones, but the the hexadecimal is a lot easier to read and parse, by computers and by us. So I'm going to go ahead and do that. And you'll see, kind of looks like the matrix just kind of goes crazy. It actually flooded my SSH connection and forced me to disconnect, but it still would work for this purpose. Basically, you're going to see every line here is just the, right here, is the hex values for a part of a transaction. This is just a line number, so you can disregard this. And then this over here is just the ASCII, data that has been parsed from this hexadecimal. Really, it's just garbage because this isn't meant to store text. This is storing, transaction data and values. But in previous episodes, we've showed you how a transaction is usually built, and we've showed it to you by using this website here, blockchain reader. And let me just go ahead and zoom out here a little bit. But you can see, for an example, here's a raw Coinbase transaction, which is usually the first transaction in every block. And if you remember, the Coinbase transaction is basically what the miner uses to pay themselves with the block reward and the transaction fees. So every block will have this transaction, and it usually starts like most other transactions start, is a 0, 1, 6 zeros, another 2 zeros, and another 0, 1, which is the witness flag. So if we can actually look over here on the left, you'll actually see where we can see that pattern appear. You'll actually see the 0, 1s here, then the 6 zeros, and then a 0, 1, which is the witness flag. So this looks like right here, without even looking too hard, we can actually pull out a transaction just by selecting this and looking for the end of the transaction, which is usually, or it can be at least, 8 zeros, which is the transaction lock time. But I'm not going to do it in this view here because it's a little difficult to view. I'm going to actually open up this application called HexFiend, and it's just a simple hex editor. I loaded up this block dat file that I just exported. So this is a 134 meg file and it just contains a ton of hex data. I mean, if I scroll all the way to the bottom, you can see it contains about 80 million lines of hex, at least in this, this view. But what I can do is I can just search for the word mine, for example, like as in mined, and you'll see it found some ASCII characters that say the word mined by GB mine, or GB miners, which I assume is a mining pool or a miner, and this is kind of where the Coinbase transaction is. As you can see on this right hand side, we're looking at a raw Coinbase transaction in a block, and it actually has some data encoded in it. In this case, it has BTCC encoded in it to kind of show who mined that block. And this is similar over here. This particular block was mined by GB miners, and this is the beginning of the Coinbase transaction here. As you can see, you'll see a lot of zeros in the Coinbase transaction, and that's because there is no previous input that the Coinbase transaction is spending. There was no block or Bitcoin sent to the miner. It's really creating Bitcoin. So there is no input, so there's no previous reference to Bitcoins. So you're just going to see a lot of zeros here in a Coinbase transaction. So they're kind of easy to find that way, and you'll see the many zeros here on this side as well. Right before all the Fs, which you can see here on the right hand side, the Fs are there as part of the previous output index. But basically, this is where the miner will put in the block reward and the transaction fees, total it all up, and just kind of write a check to itself. And of course, if this block is validated by the nodes as being correct, then that miner will get that reward after about 100 blocks have passed. So that's just kind of showing you here how it looks raw on the disk. It really is just a bunch of strings of transactions in hex. In this case, starting with the Coinbase for the beginning of the block, and then right after the Coinbase, there's going to be another block, or another transaction, I should say, which will begin the transactions from the users of Bitcoin. Now I can do just a little search here for what usually a block or transaction, I apologize, starts with. It usually starts with the 0, 1, as I said before, with the leading zeros, or the leading zeros, and then the witness. In this case, it's usually the witness marker and the witness flag, and then the number of inputs. In this case, I found a transaction earlier in this file just by searching for that. Actually, I'm just going to go ahead and find another one here. I apologize, it's not finding the way. Oh, so I'm searching for text, that's why. I don't want to search for text, I want to search for hex. Previously I was searching for text because I was searching this side. I was searching the ASCII equivalent of the hex for the word mined or miner. In this case, I actually want to search the hex hexadecimal values for a certain pattern to find the beginning of a transaction. So if I just go ahead and paste in the first couple of bytes of the beginning of the transaction I want to look for, and I click next, you'll see it popped up here, and it's kind of hard to see, but you can see it started selecting the hex that I searched for. And this actually is the marker for the beginning of a transaction. You'll see the transaction before it ended in 8 zeros, which is usually the transaction lock time, or when the transaction will be included in a block, and all zeros means it'll be included in the soonest available block that it can be mined in. Otherwise, this value can be a block number in the future, or a timestamp in the future, and that transaction wouldn't exist in the blockchain until that time occurred, or that block number occurred, or after that block number occurred. But in this case, I'm just going to show you the beginning of the transaction here. There's a lot of hex here. I'm not going to try to break it down. I mean, that's really what our previous episodes did, where we broke down each section of the transaction, such as the script pub key, the output values. In this case, we also have this, the witness item, because it's probably referring to a it's referring to a SegWit transaction. And let's see what else is included in there. The previous transaction hash is included in every transaction. So what I'm going to do is go ahead and just grab this and show you. If I just select it down to the very end of this transaction, which should be where I see 8 zeros here. In this case, it actually keeps going because this is a much larger transaction. It looks like right here we see where the transaction ends. Usually the script pub key, as you see on the right hand side, ends in the opcodes 888C, and you can see, if we look over here, we see 888C as well, and then we see the lock time. So if I look at it right here, well, it's better if I actually load up the transaction list to show you here on the color coded side. This is a bunch of transaction IDs in the current block. And if I go here, you'll actually see the transaction lock time down here is all the zeros. And then in this case, it's giving me the witness item data because this is a SegWit transaction. The example I'm doing right now is not a SegWit transaction, so I'm just going to go try to find another one that is not a SegWit transaction, which we will go into in the future episode and kind of break down what SegWit is and how it looks in a transaction. But I actually found a non-SegWit transaction here. You can see the transaction ends in the opcodes 88AC and then the lock time. So similar to the transaction I found in the raw hex, 88AC and then the lock time. That looks like that should be the end of this transaction. So the beginning starts with the 0-1, the end, not always, but a lot of older traditional non-SegWit transaction ended this way. So now I'm just going to go ahead and copy this out, and I'll show you if I just paste that, if I go in here and copy it out and paste it in, let me just do a copy, paste, you'll see this is the hex of that transaction I just copied over on the left, and I'm going to remove all the spaces. just to kind of compress it down into just as a long string of serialized hex. And then I'm going to copy that, and I'm going to try to decode that using the block cipher decode a transaction site. And this is a decoder that we used in previous episodes to basically parse transactions that we were trying to build ourselves manually and then submit over the testnet, which actually we got working in our last episode. So I highly recommend checking that out. It's the constructing a transaction episode. But in this case, I'm kind of dissecting a transaction already made. So I'm going to paste it in here, and we're going to go ahead and do decode transaction on the Bitcoin network, and hopefully this will work. And it looks like it did. So you're going to see this kind of human readable output. This is the JSON output that is used usually, for APIs, and websites to read easily, as well as us to be able to read. But you can actually see that it pulled the addresses out of that hex that the data was being sent, or the Bitcoin was being sent to. It also shows the previous transaction hash, or actually, I'm sorry, the current transaction hash here. So basically, the hash of this hex data here is actually this number here. And then the input address, looks like there's two inputs. So this person's actually sending Bitcoin from two addresses, it appears. And then they're also sending out to two addresses, which looks like one is the recipient and then one is the change address. And the way I can tell that is that because this address here is actually the same as one of the input addresses. Actually, it looks like it's the same as both inputs. Yeah, they're both the same. So both input addresses are the same. But there's two different transactions that they're referencing to send Bitcoins from. It's two different unspent transactions that they're referencing from the same address. And then they're sending, looks like 4.3 million Satoshis to someone. And then they're receiving back, it looks like 11 million Satoshis back to themselves. So they're sending 4.3 million Satoshis, but the remaining balance is coming back to them, because that's how Bitcoin works, is that you don't actually send a portion of your balance and your wallet. You're sending pretty much all of the previous transaction total just to in a transaction, but you're sending part of it to someone and then the rest of it to you. I apologize if I'm not explaining that correctly, or the best way, but basically it's like giving someone $20 for a $10 item. You give them 20, they give you 10 back, and that's your change. So that's basically what's happening here, is that you're sending a total of about 15 Bitcoin, but only not 15 Bitcoin, but 15 million Satoshis, and then getting 11 million of that back in change. So basically what I want to show you here is a little easier to view way of this transaction. So we're just going to grab the transaction hash here, and then just do a little search for it in search bar here. So this is basically the unique transaction identifier. Now BlockCipher's searching for that, and here you go. You can see that the amount that was transacted, I was a little off. It was actually 16 million Satoshis, or 0.16 Bitcoin. The fees that this transaction, basically how much this transaction cost to be executed, was 0.007 Bitcoin, and then it was received 4 days ago, so it's a couple days old, and it has been confirmed at least 6 times, so within 6 blocks, which is usually around an hour if each block takes 10 minutes. And then scrolling down further, we also see that we have 2 inputs, just as I showed before. Looks like 0.08 Bitcoin from this address, and then again 0.08 Bitcoin from this address as well. And then 2 outputs, and 0.04 was sent to the 3J5 address, and then the remaining balance was sent back to this 1J3 address. So you can see the 1J3 is the 2 inputs and one of the outputs. So that's the change, we can safely assume. May not be correct, but more than likely this is the change. Now this here shows that this this balance, this 0.04 Bitcoin, has not been spent by whoever owns this address. This address could be owned by the same person that sent it. It could just be moving money around for whatever reason. We can't tell. But what's cool is that we can tell that it hasn't been spent, because this transaction has not been referred to in the future. It hasn't been referred to since 4 days ago in another transaction to be spent. So the block cipher site can safely say that this is an unspent output that's just sitting in the blockchain, and once it is spent, though, we should be able to see a reference to it in the future if we were to go back and see where it went and what address it went to. So basically what I just want to recap is what we did is first of all, I was just connected to my Bitcoin node, which I'm just going to reconnect here. This is just running on my Ubuntu server that I have on my desk here. Nothing special, just 8 gigs of RAM. Doesn't even need to have that much. I also run my other services on here. And I'm just going to go to this Bitcoin directory, show you the files here, and then we're going to go into the blocks directory, and you see the files that store the blocks. We just basically outputted the hex from one of those blocks, kind of went through it, and knowing what to look for, we were able to look for the right pattern, and then we pulled that out and then deciphered it and then looked it up using a block explorer to see what actually happened. And no, if we wanted to spend more time on this, we could actually not do this on the block explorer. We could actually decode this transaction ourselves offline. It would just take some time, and it's just a little tedious. So for this purpose, I thought this block explorer was good enough. And also, if you go to, looks like I lost my connection again. Gotta love live YouTube. And the fact that I can't type my password correctly. And now we're going to go back to that directory. I thought it was kind of cool because you could actually see the mempool, or at least data that's stored in this mempool file, by doing the same command, the xxd mempool.dat, and then just running it. And you'll see, if I look for a pattern, beginning of a transaction pattern, I should be able to find the beginning of a transaction, which that looks like it could be it. Looks like we'll have to go a little bit further up. But earlier when I was playing around, I was able to find the beginning of a transaction, which looks like that's part of a transaction, another part of a transaction. It's a 0-1 pattern there. And yeah. So really, the neat thing is that you can see the transactions that haven't been included in a block yet by actually looking at this mempool.dat. I'm not sure how often this file gets updated. Again, this file is a couple days old because I haven't fully synced my node. But I thought it was neat that we can actually look at the transactions. And that's usually something that you can see on Mempool stats. A Mempool stats website, such as like blockchain.info's mempool size. You can actually see the number of transactions that are currently in the mempool, which is basically all the transactions that haven't been confirmed yet, that are waiting to be included in a block, which would then make them confirmed. Whereas you can see that the raw data of these transactions is living on my node or other nodes, and that's where this data and this number is coming from. So yeah. I hope that this kind of helped kind of demystify it a little bit. I know a lot of this, is just difficult to read. I just kind of wanted to show that, it's not magic that's happening. You're actually, when you actually send a transaction, it is going to a server like mine that's sitting on my desk and being validated there, being broadcast to the miners, included in a block. And once that block has been built and hashed, it's then sent to all the nodes for verification, and then stored on those nodes, so that way that those transactions can be verified later on, when basically when the inputs and the outputs have been spent in the future. So I just kind of wanted to demystify all that. Otherwise, if you guys have any questions, let me know. Post in the comments. Give us a thumbs up, share this video. Subscribe if you want, and I appreciate you stopping on by. you guys have a good night, and we'll see you hopefully next week.